Welcome to the channel, guys. I'm Steve and this is Working On It. Today we're going to take a look at this wood stove that I built that heats this building. This building is 40 by 60 and it's almost no insulation. Some places there's no insulation. Some places I've got a little bit of foam board up, but that's a project for down the road. So this is my wood stove. This is a wood-fired boiler. I built this out of some old tanks and a bunch of junk, and when I bought this property, this shop was a dirt floor, and I ran tubing in this entire floor, and I don't know if I can find a picture and figure out how to put that in the video, but there's 1,500 feet of PEX tubing. This is 1/2-inch PEX that runs in a grid on 1-foot centers through this floor, and this manifold controls all that. So let me kind of show you this wood stove. So this section is the wood stove. This is an air-to-air heat exchange, and this is a water tank. So this tank is full of water up to about here, and what we have going on is on these lines here. So the water comes out of this line. Let me spin around here. So the water comes out of this line, comes down across the floor, goes into this little Grundfos pump, which pushes it up, and it goes into this hot water tank. This hot water tank is an auxiliary. If I ever wire it in, this could heat the building without the wood stove. This comes down, enters this manifold. Each one of these are a flow control, and I can control each of these 5 zones individually. So water goes down into the floor and returns up to here. This is the cold side. This comes back down, goes back down here, comes up and returns into this tank, and it's just a constant circuit in there, and it goes around and around. We got a fill cap, and we're holding about 10 psi or something. It's from what I've found, the psi doesn't matter as long as you pressure test everything so you don't have leaks. And we got the pickle dog. Get your ball. So these tubes are, I cut holes with the plasma cutter, and they go through the firebox. And then I've got, basically I took a piece of square tube and made a manifold. And then this fan is kind of the cheapest little squirrel fan. Well, really when I bought this fan, I was going off of decibels and how loud or how quiet it is. And that's on high. It's not noticeable, but it picks up on audio pretty bad in here. So I usually run it on low. But anyway, so this is sucking cold air from the room, and it's blowing it through every one of these tubes. And these tubes go through the fire and come out here. So these tubes are pretty hot. It's really kind of hard to get a reading, but you know, these tubes are like 300. You can't really hold your hand in front of that. It's burning you like a heat gun or a hair dryer. That's nice hot air coming out into the room. So this tank on top, it doesn't get all that hot. When I built this, I thought I'd see higher temperatures, but right now we're about 65 degrees on the water. And what's neat is it doesn't get hot, but it's warm and dry, so you can stack gloves and shirts and stuff up here and it just dries them out. So the way this goes, you've got fire down in here, and it comes up and it hits these tubes, and there's a steel floor right there on top of those tubes that forces all the fire and heat to come down to this end, and it turns and it comes up here and it runs along the bottom of this tank, which is cut into that tank and saddled in there. And then we come out here, and that goes up into my chimney. That goes up out of the roof. Now, this is called a magic heat. That's just something, these are like $600 or something. I found this on Marketplace for 75 bucks, and I just put it on. But it's, again, it's got a little thermal sensor in the back, or you can turn it on, but it automatically, when the flue gets hot enough, that fan kicks on and it's blowing heat right out of this thing. and you're just saving a little bit of extra heat and blowing it out into the room. It works good. So my hinge on this thing's very thick, and it didn't have to be that thick, but it was something I had that I scrapped a great big off-highway truck, and this was one of the tanks on it. So in here you can see, I don't know if you can see that metal plate. Man, it is hot in there. But you can see those tubes. That's where the draft air comes up through this thing. And I still have not ever put a latch on the door. It doesn't seem to be an issue. This rectangle tube here is welded to the base of this stove. Now that goes out through the wall, and that sucks cold air from outside the building. It's got a grate on it. And then I built these guys, and that's my draft control. And I just put, if I want it down in there at the end of the night, I just drop that in, and it slows the draft down, because the air comes in through this, comes up through these tubes, and then it comes up through those tubes, and it is hot. So that air comes in and it comes up through there. So I can control that draft element. On this side I've got the same thing. So the air comes in through this base and it comes up through those. So ideally I run that draft control at about a quarter opening, and the air comes in through here. It goes through all that fire and comes out, and then it comes up through here. There's also a butterfly valve in the chimney. If I ever had a runaway or it got too hot, I can close that and shut the fire down. So I will add, I'm running straight water. I don't have antifreeze or anything in this system. It's never been an issue. I don't think it will be, but I'll probably put some kind of, maybe I'll put some used automotive antifreeze in it at some point. But currently, if I were to shut this unit down for several days and not have a fire in it, it was cold enough, it could freeze and break some of this stuff. So for safety, I probably should get some antifreeze in this thing. So the beauty of this system is the floor stays warm. Not hot, it's not hot, but it's warm. When you're in here and you're crawling around under a machine working on it, it's not cold. You don't even need a creeper. If the floor's clean, just crawl underneath. That's the worst thing being a mechanic in the wintertime is being on cold concrete and your feet are warm. It's just really nice. So everything in this building warms up to temperature. Your wrenches in your toolbox, everything is just, it all climatizes. And the beauty of it, I can open that door and pull rigs in and out of here, and you don't lose all the heat because you're actually heating the structure of the building and the floor of the building. Now, if I just had a diesel heater in here and was just heating the air, when you open that door, it's instantly cold. But having the floor heat, as soon as you open that door, get a rig in and out, close the door again, it's just back to being warm in here. It's amazing. So I insulated the slab, so the ground underneath this concrete slab has this stuff. It's bubble foil insulation. It's about a 1/4 inch thick, and I didn't go with the 2 inches of foam board due to when I poured this slab, foam board was just astronomically expensive. So I went with that double bubble foil, I think they call it. And I ordered that stuff off of a company called Uline. They delivered it, and it was the cheapest, best alternative for me. And it works, seems like it works great. I don't know, if I'd have put down 2 or 3 inches of foam, maybe this would work better, but I don't have any negative that I can see having used that bubble foil. Now, if you're in a climate that gets a lot colder than it is here, you probably want all the insulation you can get. So I will say, I'm in Western Washington. We don't get super cold most of the time. You know, generally in the winter we'll have a snowstorm or an ice storm, but generally, you know, you're in the 30s, 40s, and 50s most of the time, and this stuff works great. Now, if it was sub-zero all the time, I'd probably tell you to put 2 or 3 inches of good foam board down. I don't know if I'll be able to upload these pictures, but this is all that PEX tubing. You can see the insulation down there, and you can see I'm on a 1-foot grid with all my tubing. It's all put down with zip ties, and this whole shop is just laid out into 5 zones. Here's the concrete guys starting in, and you want to keep them about 1 foot apart. And then I did some spray foam on the edge, and then I also for the guys to pour to, you can see right there, there is foam board that's screwed to the 2x6s on the outside edge of the shop, and that was set laser level. And there's my conduit 90s that were mounted just to keep all that stuff laying how I wanted it for the concrete pour. When we poured the concrete on this slab, I pressurized all this tubing to, I think, 50 psi. It might have been 100 psi. And that way, if somebody somehow punctured one of these lines, we would know it. And we did actually pop one on a piece of the tie wire for the rebar. So if you're tying your rebar down, make sure those little tails stay away from the tubing, because that's what happened. And they make what's called a shark bite fitting. Keep a handful of those somewhere where you absolutely know where they are during the pour. And if you have to, you can cut that line and pop that little shark bite together, and you fixed it. Now you turn your air compressor back on, charge it back up. You don't have a leak, you're good. But that's how we did this. It's called a shark bite fitting, and it's 4 PEX. And I had like 5 of them on the pour day, and fortunately we only needed 1. And everything aside from that, the system's been running for 2 years, and there's no leaks. We have a small crack in the floor, and it didn't leak there. So okay guys, I'm gonna wrap it up right there. My last video on this from last year, I had some different questions and guys wanted a little clarification, so I hope this helps you out if you're thinking about heating your shop with from the floor. If you have any questions, shoot me a comment down below. I'd be happy to answer anything I can help you with. And if you guys want to see more on this system, let me know. So have a great day. Thanks for watching.